Alright, so here's the latest one. There's a hub mounted to the shaft. Little set screw. Screws in up top. Messed up with the measurements, so we had to chop up the bolts here. Otherwise they whacked the coils. There's a clearance on the coils. This thing spins pretty smooth. We just kind of held up like if you spin it, hold up something and wait till it ticks to center it. That way you can kind of move the wheel around. I've jigged with it for a long time and it's about as good as it's going to get. But it spins pretty easy. So the magnets are stuck in through the bottom with little brass screws holding them up. I don't have the hawse on, or the hawse on yet. But those are where the magnets will sit. Runs okay. I'll fire it up in a second. Right now I'm just coming off here with 2 leads, so I'm only using 1 coil. And I noticed the closer you get the rotor to the coils, the more voltage you get, the further away. Which I mean makes sense, but it's nice if you want to fine-tune that for testing or whatnot. So right now I'm only hooked up to 1 coil. And I'll kick it on. So I can get it down a little bit from there, but for now I'm not going to mess with it. So you can see we're hooked up to one of the caps. Now we're running at 20 microfarads. Here was my log. And I'll kick this on. And you can hear the tone change. Right now I'm only putting into one of them, so 50 volts per division. And I don't know why my scope does that. When it first starts up, it's like it's reading the voltage properly, and then now it goes away. So I'm going to turn it off. See, sitting there we have 118 volts. I'll turn it on. Now this was the absolute cheapest scope I could find. It was like $200, so I don't know, maybe that's why. But it goes away, which is weird. So if you turn, let's go. Okay, so it goes up from 97 to 125 watts. That's what my scope's looking at now. I'm gonna turn it off. Drops back down to like 95 in a second. They're sitting. We can't turn them both on unless the capacitor holds higher than the neon trigger voltage. So we're not making a voltage trigger 2 at the same time the way this dial plug is set up. So I don't even know what the hell I'm supposed to go by on this one. So I try to grab that first instant when it was working good and go from there, because the up and down of it doesn't seem to matter too much. So right in this range, right around that 20 range seem to be where at least I get the closest anyhow. None of it's good because all of my watts increase on the RV anywhere from 27 to 43 watts, you know, and I'm never really making up for it. This one here, I think this was a fluke number. I was kind of going on the higher part, but I'm not sure. Maybe that is correct due to the scope. So here's one of Hector's. I was gonna maybe try this one next because it doesn't involve a neon. Before I start rigging up the hauls, because this one it's fine for when you're doing half of the diode plug, but then when you add the other side, well, actually on this one it wouldn't matter because you're triggering off the same one. On the ones where you trigger off the opposite sine wave, if that capacitor voltage doesn't give up high enough, then you don't trigger the opposite pole, if that makes sense. So what else is I going through here? Oh yeah, the transverter thing. So Hector gave this one out a while ago. I downloaded it and printed it a while ago. So we're looking at these band pass filters. This is another going to this book's got a lot of stuff in it. So here's the example of the resonance with the node and anti-node. I've been looking at this for a while. I guess I'm not exactly sure where is which. I'm pretty sure in the capacitors where your voltage is, as obvious, maybe. And then I think the current is in the inductor, and then the resistor turns into the inductor. I'm not sure. I'm going to have to review that. But this is Dan Combine's outputs on his video. So he had roughly 250 watts going in on this transverter. So you don't use the middle leg. So he had 2900 var circulating. These are his results. So I'm thinking theoretically if you had 173 watt bulbs at 19 amps, whatever, match that up, that's what you should be able to light that up perfectly. But that's probably going to reflect. Now here's where I'm confused. Is that going to reflect that much on the input then? Or just a little bit? I think it's just a little bit is supposed to reflect on the primary. So I got that H bridge working and I'm trying to match up. So once I have, for instance, these, whatever I want to plug in there for a resistor, when Hector's talking about the bandpass circuits, so this would just be a reactance start to cancel it out. So you can find out what it's going to be as a pure resistor. Now that's only when you're resonating something. If you had 100 ohms in here and you resonate this, capacitor will cancel out, the inductor will cancel out, and you'll see the pure resistance. Say it'd be 100 ohms. Now when you put that 100 ohms over here, it won't reflect directly. So aside from just sweeping the frequency range to find out where it works, there must be some way to line this up. If anyone can point me in the right direction, I'm willing to read it. But go back up here quick. I shut this off quite a while ago and this thing's still spinning. So I know it's reasonably balanced. But my input and output is not good. Hopefully maybe that changes as the coil shorting gets added. I hope so. Because right now this sucks. So if you guys want a better look, there's room for more. And then these are tapped up here too, so I can screw these extra coils or whatever right in. But for now, nothing good.